Now let's look for a numerical pattern. To change 1/2 into 2/4, we multiply the numerator by 2. 1 times 2 equals 2. Then we multiply the denominator by the same number. 2 times 2 equals 4. The key is that we must multiply both the numerator and denominator by the same number. That keeps the fraction's value equal. You might be wondering why multiplying both numbers doesn't change the fraction's value. When we multiply the numerator and denominator by 2, we are really multiplying the fraction by 2 over 2. And 2 over 2 equals 1 whole. Multiplying a number by 1 doesn't change its value. That's why the fraction keeps the same value, even though its numerator and denominator change. Let's find the missing numerator. We have 3/5, and we want an equivalent fraction with a denominator of 10. First, ask, what do I multiply 5 by to get 10? 5 times 2 equals 10. Since we multiplied the denominator by 2, we must also multiply the numerator by 2. 3 times 2 equals 6. So 3/5 is equivalent to 6/10. We don't always have to multiply by 2. We can multiply by any whole number, as long as we use the same number for the numerator and denominator. Here, we'll multiply both parts of 2/7 by 3. 2 times 3 is 6, and 7 times 3 is 21. Therefore, 2/7 is equivalent to 6/21. A fraction can have more than one equivalent form. If we multiply 1/4 by 2 over 2, we get 2/8. If we multiply it by 4 over 4, we get 4/16. We could continue this pattern again and again. All of these fractions are different names for the same value. Here's a common mistake to watch out for. A student might multiply the numerator by 2, but forget to multiply the denominator. That changes 2/3 into 4/3, which is a completely different value. To create an equivalent fraction, whatever you do to the numerator, you must also do to the denominator.